In this video, we will derive a numerical method called Fromm's method from our previous general equation that is written over here. This was the general form of numerical method which consists of slopes. These are the slopes. This is slope at cell number I, and this is slope at cell number I minus 1. So what we do, we consider this general form of numerical method, then put the value of this slope over here. For Fromm's method, we have a center difference scheme. The slope, you know that the slope is defined by the derivative dy by dx, and if we define the slope at cell I as center difference yi minus 1 to delta x, then this is called the Fromm's method. When I replace I with I minus 1, then we can write this as I and I minus 2. So we put all these values over here, and sigma and I, which is slope over here, and we get the Fromm's method. It is very simple procedure. You just need to understand this equation which I already derived in my previous lecture. So what we do, we simply put the values over here, and we multiply both, we simplify, in fact, we simplify these terms. On the left hand side, it should be qn plus 1i. It should be qn plus 1i. And this can also be written as, you just take LCM and solve it. Finally, you reach at this value, so on. So this is actually the Fromm's method, a very simple procedure. You just pause the video and see yourself how you can define it. There is no standard procedure where you can put maybe qni plus 1 or qni minus 1, or maybe you can put I and I minus 2. So this is the Fromm's method. This is the Fromm's method. Thank you for watching.